using this place. Because at the center, the load is natural. So beside the side of the structure, the load is small. So the depth of the foundation is at the side of the structure. The depth is small. At the center is natural. Okay. So the net average, the pressure at the bottom of the foundation, we can use this one. This is the net average apparent pressure on soil. This Q is cup Q. Cup Q is the load, gross load at the top of the foundation. Okay. Yeah, by A arrow, then we can got the pressure at the bottom of the foundation, and this matters the gamma times dF, times dF. dF is gamma, and dF is the rate of the soil between up the depth of the bottom of the foundation from the bottom of the foundation to the surface of the ground. Okay. For no reason, the net pressure on soil below or mat foundation, the Q should be 0. Then the dF. Yeah, then we can from this equation we can get the Q equals the dF multiplied by the A arrow of the gamma D. Arrow of the gamma D. So for example, this Q is 0. Yeah, this Q is 0. The factor of the safety against the California for particularly competitive foundation is given as follows. This is factor of the safety using the QNet and your ultimate QNet ultimate by the Q. So we can get the QNet. QNet is net ultimate velocity times the QA by QS. This is how to calculate the FS. For such a declaration, the factor of safety organ California can thus be obtained by the equation. This is Q ultimate dynamic capacity, ultimate capacity for the such place. Yeah. Okay. This is about how to calculate the factor of the safety. Something on there. Another question is structure design of mat foundation. So when you to design the shallow foundation, the mat foundation, two methods for structure design of mat foundation we can use. This is conventional rigid method, approximate flexible method. So this is just for the rigid mat foundation. This is for flexible foundation. Okay. The step-by-step process for conventional rigid method refers to the figure. This is the mat foundation. This plasma is square one is the copper. So this is the matter. From there to the figure and to on the Bonnie standard. So the figure A we can see. So you can see this is the center of the mat foundation. So this is the width of the foundation. This is the total length of the foundation. So this is the couple A, B, C, D, E, F, G, H, I, J. K. Okay. So we take the a section from this one. We just take this one to the IHGF to this section. Yeah, this section. We can see this is the load from the copper. From the copper Q1, Q2, Q3, Q4. Maybe the Q1 don't equal the Q2, Q3, Q4. Maybe the load is not the same. Maybe But if the vertical is if the load is vertical and no inclination, this Q1, this load is the same. This load from the cable is the same. If the cable is the same, so the pressure at the bottom of the foundation is the uniform. Is uniform. Yeah, next to 9. Yeah, the pressure next to 9. If the Q1 don't equal Q2, Q3, Q4, maybe this is this distribution maybe it is not ununiform. Yeah, it's ununiform. Maybe like the traction or vector and so on. Yeah. So the steps, the process of how to design the rigid mat foundation is this one. From the step 1. First one, you calculate the total canal loads as Q. This is total loads. Add the Q1, Q2, Q3, and so on. Sixth step, determine the pressure on the soil below the mat foundation at points A, B, C, D with the equation. Yeah. A, B, C, D with the point A, B, C, D. So use the Q by arrow, by the arrow is the B, L, is the B, L, and or minus, minus NY, X. And this we can see this figure. This is the X4. Just for this is A. This is A. Yeah, you can see this. So this X is from this point, to this point. Yeah. So it's B1 and B. This is B. From the distance from this point to this point is X. Is X. You can see, yeah. And Y by I1 is the moment enter about the Y axis. Or minus MY and XY. Y is this way. In one would be so from this point to this point. Yeah. From this point to this point. Okay. So use this one we can got the Q, this is Q. Okay, the load electricity of X Y in the XY direction can be determined by using X prime, Y prime coordinate. Use this one, this equation, we can got the X prime, Y prime. Okay. So step 3, compare the value of the soil pressure determined in step 2 with the net orbital soil pressure to determine whether. So this we can calculate from the step 2. So the Q orbital we can calculate by the Mayhoff or Tasakis equation. So this we can calculate. This is 2. If the Q is less than the Q net or Q orbital, so your design is okay. If the Q is big than the Q net or Q orbital net, so then you can redesign your the foundation. Maybe you can increase the size of the foundation, increase the width or the length, and so on. Maybe you can increase the depth of the foundation and so on. Okay. So if you increase the size of the foundation, this value we are small, very small, and this orbital we are increasing. This is the step 3. Step 4, you divide the matter into several strips in the XY directions. Let the rest of any strip be B1. Yeah. This is divide the matter into X and Y. Yeah. This is divide the matter from by the x direction and y direction. Then we can go to the matter. This is a strip matter. Strip matter. And then step 4, draw the shell V and the moment M. Diagram for each individual strip in the XY direction. For example, the vertical soil of the fourth strip in the X direction, big F would be Q1 and QF by 2. Q average. Q1, Q1 is the soil at the point A, I, and F from the step 2. Yeah, from this first name you can calculate. So the total soil reaction is equal to Q average. Soil reaction is Q average B1 by B. Now we can obtain the total cardinal loss on the strip as Q1 and Q and so on. So the sum of the Q loss on the strip will not equal Q average because the shell between the adjacent to strip has not been taken into account. So for this reason, the soil reaction and the nodes need to be adjusted. For you can use the average node, use this one to replace use this average node to use this one to replace to this one. Okay. So the major average will actually become the Q average node by Q average B1 by B. So then we can go to the cardinal node multiplier fraction. This is the factor of the cardinal node. And this step 6, you determine the effective depth of the matter by checking for diagonal tensile shell near various curves. For the curriculum nodes, we see is bigger than the U. U is the effective cardinal node according to ACI code. Yeah, this is ACI code. You can this VC is shared with the cardinal location. This is about the from the materials. Maybe you use the concrete, you can calculate the VC. Okay. About the VC, looking at the ACI code from the non-presence snappers. And first uses the smallest value for VC from the following equation. Yeah. This is the shear strength of the concrete. So use this formula to calculate the VC from the code. Okay, we just know it. And so on. This is the effect, or the parameter from this VC. B is the ratio on one side to short side of the column. Here is 40 for interference, 30 for integer, 230 for quarter columns. B0 pyramid of the section of the shell favors the compressive stress of concrete 28 days. Yeah. So this part you can start it in the principles of the structural design. In the structural design, we can use this one. From this equation, if they study the principles of the structural design.
Principles of structural design.
Principles of the structural design. Yeah. This is this equation. This is from the ACI. Okay. Maybe you forgot it.
Which one is that?
Okay, and this is Namica is a modification factor beneath reflecting the reduced mechanical properties of natural concrete. What we next to normal red concrete of the same precious. P is the effect depth of the mat. Okay. And the expression for B0, yeah, this is for B0. In terms of the D, which depends on the location of the color with the reflection of plane of the matter, can be obtained from the following figures. For this one, this is age of the matter. Age of the matter, the kind of B0 is equal 2 times Li, and L square bra, square bra. This one bra. This is as the comma is as a column. The comma is as a column. This comma is at the center. This comma is the center. This comma is at the side of the matter. At the side. Step 7. From the moment diameter of the gypsum in one direction, x or y, we can obtain the maximum position and the negative moment per unit mass. Yeah, and this is mu factor moment. So we can get mx max, my max. So which one is the maximum? Using the biggest one, can use the biggest one to design the step up. So determine the error of the step bar per unit mass for positive and negative reinforcement in the x y direction. You can use the equation. This is mu. Mu is the factor moment. Phi is the factor reducing factor. As is the area of the step. Area of the step per unit mass. If y is the stress, yellow stress or reinforcement and intention. This is about the A. Okay, this is about this is the stress of the concrete effective consequence. Okay, just this one is assume the mat foundation is a rigid structure. Okay. Another method is to assume the foundation, mat foundation is a flexible method. Yeah. So the foundation, so the pressure at the bottom of the foundation, the pressure at the bottom of the foundation is negative load on the foundation. Okay. So. And approximate method for design, the soil is assumed to be equal to an infinite number of elastic springs, as shown in the figure on the next slide. Yeah, select the spring. You can give our load on the foundation. Then we are green our sediment at the bottom. Like this is also a spring. Yes. The elastic constant of this assumed spring is referred to as the coefficient of the subground rotation, K. Is the factor of a spring. Is a factor of the spring. Yeah, this number is based on the materials of the springs, next the materials of the soil. Yeah, that's my one. You give the of course Q1, give out Q1, the spring will go down, have our sediments. So in other place, if this place have no loads, so this method have no sediments. So to understand the fundamental concept behind the flexible foundation, this is the foundation design. Consider a beam or with the B1 shown in the figure. Yeah, this is like the beam. This is like the B. This is the section as the AA. As the AA. As this kind of this is the B. So we can take this section. This section AA from this section. So this is the third at the point. So we can calculate the AB. The section at the AB place with the beam and then with the beam. So based on the materialism mechanicals, we can get this equation from the materialism mechanics. So this E is the most most of the electron on foundation materials. If is the moment on interior or cross section. So this is the direction reaction. This is how to solution this equation. We can use many methods. So take the another parameter to this equation. Then we can calculate it. This is about the K. So how to design the flexion method of the mat foundation? The step is assume now thickness H for the mat for step. Occur to step 6 of the conventional rigid foundation. Then we can determine the flexion rigid use this equation. Then determine the radius of the effective stiffness. Use this K is converted from the ACI code and so on. And the step 4 is determine the moment. Moment is caused by Carnot laws. For the step 4, we use the following equation. Use this FR, FT for the radial moment, segment moment. Step 4, for the unit mass of the metal, determine the shear force with the V. If the edge of the metal is not in the zone of influence of a cannon, determine the moment and shear along the edge. Moment and shear opposite in sequence to those determine the moment at the edge of the safety to know the position. This step 7, the direction at the end point is given by this one, with this equation. So this is how to design the mat foundation, use the rigid method or the flexible method. Okay?
Okay.
So you just know because this is based on the code of the American ACI their code. But in China we have the content as a book, as a Chinese book. You can see as the chapter 2. Chapter 2 is about the China foundation design. Then we have our example. Have our example in the chapter 2. Chapter 2 is the China foundation. And you can see this is foundation is the spring footing about the strut. Use it as a bridge. Yeah. This is thank you. There is also the example
I'm recording.
in the page.
What page number, Jones?
In the page 57 and 57.
Okay.
And the Chinese book, you can see, you can see the process of the. Okay. So have a rest. Okay. Okay. So this is the process of how to construct. Construct. About the tile foundation, the structures members that are made of steel. For the steel pipe pad. Steel pipe pad. For the concrete, or the timber. Timber. But if we are but the timber, recently using, you can't use it anymore because I want to keep the tree, yes. But many years ago, if we don't have the steel and then the concrete, so then we just have to use the timber to build this foundation. Okay. Use this to build pipe foundation, which are deep and cost more than shallow foundation. Yeah. But the bare capacity of the pipe foundation is big. It's 90% is better than the shallow foundation. Yeah. So that the cost, the use of the pipe foundation, you often is necessary to ensure structural safety. Ensure the ground. So this is why people want to use the pipe foundation. Okay. Which the condition you shoot for the pipe foundation. There are these some of the conditions that require pipe foundation. First one is when one or more soil clays are highly compressible and too weak to support the load transmitted by this. Yeah, for like this one. So this is a software, soft soil, or the weak soil, maybe like so they is compressible. What the moisture contained is very high. So they can support the structure. Yeah. So this one. So I use this to transmit the load to the surface, to the depth, and or to the rocket, So for the loads to the underneath bed rocket or strong soil lift, show the figure. Okay. So. When the bedrock is not in contained at a reasonable depth below the ground surface, I use it to transmit the structural loads to the soil gradient. So the resistance to the primary structural loads is varied mainly from the friction resistance developed at the soil pipe interface. Yeah, this is a friction. Because the bedrock is very deep, very deep. So we can, so the bottom of the pipe is not at the bedrock. We can't set the bottom of the pipe to the bedrock. Then the supporting, the supporting by the pipe is from the friction of the pipe to the soil, interface. Yeah, this is second condition is when subject is to horizontal force. Yeah, you see it, this horizontal force, like the wind or the earthquake. Yeah, that's all. Yeah, but from the resisted by bending, was there support to the vertical load transferred by the support jack. Yeah, support the vertical loads and the naturally horizontal loads. This time our situation is generally encountered in the design and construction of also retaining structure, and the tile foundation structure that are subject to high wind or to earthquake force. Yeah, this one. In many cases, expensive colorable symbols, soya may be placed at the center of a purpose structure. If it's an expensive soya, when the word is insert to the expensive, so the soya will expand. When the water is out, it's shrink. So expensive soya swell and shrink, and the moisture content increases and decreases. And the pressure of the swing can be concentrated. In shallow foundation, I use it in such circumstances. The structure may suffer considerable damage. So the pyration may be considered as an alternative when the pile expands beyond the active zone, which is where this one and this one come. So like this one and this one. This is vanilla sonia or the expensive sonia. So we can transfer the node to this one, step source, so to this one. So we can reduce the influence of this soil, when soil is expensive soil. So soya such as loose and classified in nature, when the moisture content of this soya increases, the structure may be broken down. Sun increase in the wide ratio of the sun induced the larger settlement structure supported by shell formation. In such case, high function may be used in which the pile are extended into stable soya layers beyond the zone where moisture will change. So in this case, the soya is stable. So the moisture is stability. So we have the soya, this water can't go out. And the first condition is the formation of some structure such as offshore planters. This is nearby the sea or river. And the basement made below the water table are subject to the uplifted force. Are sometimes used for this foundation to resist the uplift force. Biasing. Because the water table is at this place. When the water is go up, they will give our supporting the soil, support the pipe. The force is up, is not down. You can see this one, this way. This direction, this is the node. This is the uplift force. This figure, this is the node. Is the water node. Is down. This is the node. This considers the water table. And the fifth, the bridge abutment and the pier are usually constructed over the pipe foundations to avoid the losses of well capacity that shellfish might suffer from. If you use it as this one, so as so then we are the destroyer the ground, so the sand will go out. So this part of the this one, maybe you use the shallow foundation, so the depth of the shallow foundation will reduce. So maybe after some years, the part of the foundation will go out. Okay, so the stability of the foundation is not safe. So then we can use the pipe foundation expansion. And so this under this condition, we can choose the deep foundation, for example, the pipe foundation, not the shallow foundation. In this condition. Okay. So So how to design the foundation? So some tests have been conducted to practice the behavioral and the load bearing capacity of pine running and the cohesion soil. However, the machine mechanicals are not yet entirely understand and may be able to. Yeah. Maybe so we have to study the foundation. So there is a method to calculate the bearing capacity of the final of the pipe foundation in the load state and the snow ground. Yes. Yeah, this is my doctorate degree. My doctorate. Yeah. The different types of the plan or the types of the path are used in construction work depends on the types of the node to be carried. The subsoil condition and the location of the work table. So different types of are used in construction work. Because what? You just read the construction work, maybe is one table is very high, so we can't use people. You can shoot for people to construct the whole construction. Then you can use the machine, or another method to construct it. When the load is very large, so the depth of the pipe or the diameter of the pipe or the size of the pipe is very big. Yeah. So then, at this condition, you need a large machine to construct. Yeah. And the subsoil condition, maybe is the soil, maybe it's the sand, or maybe is the rocket. Maybe it's the rocket. So the types of the soil is not based on the types of the soil. We can to choose the machine. Yeah. If the pipe foundation is nearby the water table, yeah, we have to construct or build a dam to keep the water out, keep the water away. Yeah. The types of the foundation we always said become based on the materials we developed to steel pipe, concrete pipe, and the timber. Yeah. So for the steel pipe, where is it? When we choose the steel pipe, or how to construct the steel pipe, we can see. Steel pipe generally are either pipe pipes or roller steel H section pipes. Yeah, it's pipe pipe. You can see. Yeah, this is the pipe. But the diameter of the pipe, but the diameter of this steel pipe is very small. But in the project, the diameter is very large. It can reach to 600 millimeter. 600 millimeter. Or the biggest one can reach to 1 meter, the diameter. And for the pipe pipes can be driven into ground with their ends open or closes. For this one, we can use the pipe pipe is closes. X-shaped run are usually preferred because their variable and flexure thickness are equal. Yeah, equal. In many cases, the pipe pipe are filled with concrete after they have been driven. If you finish the pipe pipe, then we can refill the concrete into the hole, into the pipe. So this table gives the dimension of some standard section, 6 HTL scale pipe pipes using the university. HP. This is HP. HP is the materials stance of the steel. HP. So this is the size 200 times weight. Weight is 33. So depth depth of the D1 section arrow, so section, Franklin and Weber thickness, maybe like this. So it's reverse of the D2, the moment of the intertail, X, Y, this is section, H. This is the H stage. This is the H section. Hypopad, the section of the hypopad is like this one. This is hypopad. This is the hypopad section. Let me show you. The air is spread the outside. This is the outside diameter. This is the thickness for the writing and the what thickness. This is the thickness T. This is D diameter. Outside. And this diameter outside we can the largest we can reach is to 610 millimeter. So we can do to calculate the Q orbital. Q orbital is orbital structure purposely for scale paths. Q orbital is use the arrow. Arrow is cross section area of the sphere. This section, this part. This is the arrow of section. And this Q, A is, F is the yellow, F is the orbital stress of the sphere. Or the yellow, this is F1 is the yellow stress, yellow stress of the sphere. Then we can calculate just for the structural capacity, not the high foundation capacity, just for the sphere from the base on the sphere. Okay. Once the sphere node for our pi is fixed, one should be determined on the basis of geotechnical consideration, where the Q design is within the orbital range as defined by the above equation. So when you use this one, just consider the structural capacity. I didn't consider the friction of the pi-soil interaction and the bottom of the soil to supporting the pi. When I say the step when they say by welding or by reweighting the friction, so the welding, to how to apply the pi, for an H pies, because the length of the pi is very large. So when you made the H pi from the factory, the length is the same. The length of the pi, H pi is the same. So then we can, when to use it, we can to connect this section together. Timeless method by value for a pipe insurance. Just like this one. So this is This is the one section. That means our Smith and H part by vibrator or boat, this is boat. When hard driving conditions are experienced, such as driving through dancing, river, shower, or soft rocking, step can be fitted with 0 points of shoes. Yeah, so these are step pairs. By reading, you can use this one. 2 types of shoe used for pipe pads to keep the pad to issue to the soft rock, or the hard rock, hard soil, to hard soil. And as the Myanmar maybe some of the corrosion. My soil that have a pH greater than 7 and not so corrosive. To offset the effect of corrosion, an additional thickness of steel is generally recommended. So we can the thickness of the steel, and the two divided into 2 parts. One part is used for corrosive. One part is used for supporting the nose. Supporting the nose. Yeah. So many circle is a factor because on pipe work certificates against the corrosion in many circles factor is common pipe works. All this is the same. These content are not easily damaged by pipe driver. So concrete incursions or steel pipe in most corrosive zones also protect against the corrosion. So then we can add the concrete to the steel pipes. So the general factor of the steel pipes, usually the length of the steel pipes is 15 feet to 60 feet. 15 Use load is 300 kilonewton to 1,200 kilonewton. Okay?
Yeah.
So the advantage of the steel pipe is easy to handle with respect to cut off and extensions to the reserve mass, and can stand high driving streets, can penetrate hard nails such as dense gravel or soft rock. High load carrying capacity. This is our this coverage is really costly, so it's not cheap. High level of noise during the pipe travel. You can drive the pipe to the ground will bring some noise. Yes. Subject to corrosion. Subject because these is steel. Yes. And each pipe may be damaged or defective for the working during driving through hard canals or past matches obstruction because when it's a hammer of the machine, please drive the pipe. If the bolt of the pipe is a very hard rocket. So we are destroying the pipe. And second is the concrete pipes. Concrete divides the concrete into 2 basic categories. It's a pre-cast pipe, and cast in-suit pipes. Pre-cast pipe, next the steel pipe because it is made in the factory, and then we drive the pre-cast pipes into the ground. Yeah, this is the pre-cast. And the cast in-shoot pipes is shoot for I first of all step first went to cast to cast a hole in the ground. Then we fill the reinforcement responsible the steel bar into the hole, and then we fill the concrete into the hole. Then we can finish the pad. So this pad is called custom issued pads. Okay. First one, for the pre-cast pad can be prepared by using ordinary reinforcement, and they can be square or tuckless in cross section. Yeah. Reinforcement is primarily to enable the pad to resist the bending moment developed during pickup and transport, because this pad is made in the factory. Then we can move the pad to the ground by the transport truck and so on. Yeah. So then we can consider it to pick the pad up. Yeah, this pad is at the ground. Then we can use the machine to pick the pad up. For example, then we can pick up. Okay. Then we move the pad. Maybe the pad when you move the pad, the pad maybe roll this one. So the vertical load and the bearing moment are caused by our native load. So we need more reinforcement to design the pre-cast pad. Pre-cast pad. We need more reinforcement, because when you pick up, we are creating the bearing capacity, bending moment. So this pad are caused to determinate and can before being transferred to the workspace. Yeah, this is the precast pad with ordinary reinforcement. This square pads. This is orthogonal pads. This is as a tip of the pad. Facts of the concrete pads. Usually the length of the precast concrete pad. Usually length is 10 meters to 15 meters. You also note 300 to 3,000 cubic. The advantages of the precast pad, precast concrete pad can be subject to hard travel, corrosion resistant. Yeah, because the steel pad is considered corrosion. Can be easily combined with our concrete superstructure. About maybe they have the corrosion pad but perhaps at the top of the cover with our cap and that part. Then we use the cap to connect the pier of the bridge or the structure, superstructure. Yeah, so easy to connect. The disadvantage is difficult to achieve a proper cut-off. To achieve the cut-off. Difficult to transport. Okay. And the stress in the basic one can be pre-stressed by the using of high-stress steel basic car. This is pre-stress. The ultimate bearing, the ultimate stress of these covers is about 1,080 Newton per meter square. During casting of the pad, the covers are pretentious to about 900 to 1,300. And the concrete is reported about there, around there. After covering the cover, because like this one, like the pad, yeah, like the pad. This is just the steel reinforcement. Yeah. But at this one we don't use the reinforcement. We use the pre-reinforcement. After we finish the concrete, we can pre-reinforcement. Do you study the materials
Building materials.
materials.
Building materials.
Right. Okay. Yes.
Yeah.
So this is table about the pre-stress concrete parts in use. This is the pre-fabrication. Okay. Different precast pre-parts usually needs 10 to 45 minutes. The max needs may reach to 60 minutes. So the maximum node, the organ, the grass node, maybe to reach 60, 65, 65, 100, 85, 100. Okay? So the advantage and the disadvantage are the same as those of the precast pad. Yeah. So just the difference because the difference between the stressed pile and the precast pile is the steel. The steel reinforcement is not the same. Yeah. Another passing. Second types of the concrete pile is the cast in shoot or cast in place piles. Cast in place. Building by made a hole, can drive a hole in the ground and they will filling it with the concrete and the steel. Very types are common to use it in construction, and most of them have been patented by their manufacturers. Different two broad categories are cast and uncast. The both types may have a predepth at the bottom. Predestined can increase expansion the bottom of the pipe. So we can see the casting pipe made by driving or steel cast it into the ground with a pair of man-made braces inside the casing. When the pipe reaches the proper steps of the mandrel, is withdrawn and the casing is filled with concrete. The picture is an expanded concrete to a bubble that is formed by dropping of hammer or free facial concrete. You can see this one. Some that are casting fibers are pedestal. This is a pedestal, okay? The fact about the cast in place piles usually needs 5 to 55 minutes. Max needs to 13 or 40 minutes. Usually note it's small. It's more than the precast pad. Yeah. Max note. Because in this one, we have note we first one in this part. Advantage, relative to cheap. Yes, it's very cheap because you have no steel pad. Yeah, steel pad. Yes, all very important. Better people pouring concrete. Pouring concrete easy to expand. Difficult. The difference is difficult right after concrete. Thin cases may be damaged during driving. Urban road of this concrete pad. This is about the section of the steel. This is the stress of the concrete. Two types of uncased pad. One with a pedestal, and the other with not pedestal. Some general facts of an uncased casting impression by concrete pad usually is 5 to 2. This is this. This is the maximum load reaching to 700 km. The advantage is initially economy. economical. Can be produced at any elevation. This one, the voice may be concrete if concrete is placed rigid. Differs with space of the concrete. In soft soil, the side of the hole may covering squeezing the concrete. Yeah. So all of course is just the concrete area or cross section of concrete. This is all the streets of understand. This is about the concrete part. The third types of the pipe is the timber pipe. Timber pipe maybe like the steel pipe, just the materials is not the same. Okay? Yeah. Timber pipes are tree tractors that have their version and vacuum company is trimmed off. The mass length of most timber pipes is 10 to 20. Yeah, it's a big tree, to reach to 20. To qualify for using as a pipe, the timber should be straight, sound, and without any defects. Yeah. If, when you use this tree to as a pipe, you can use deal with the tree, okay? Just to cut some timber. This one pipe is heavy nose. The minimum diameter of the water should be 56 millimeters. Because B is because I use it to cover medial nose. This is the diameter. Class C, because I use it in temporary construction work. They can be used in the purpose and structure when the entire part is below the water table. The matter bottom diameter should be 305 millimeters. In any case, our pipe tip should not have a diameter less than 150 millimeters. As the timber pipes cannot withstand hard driving stress, therefore the pipe capacity is generally limited. Steel shoes may be used to avoid damage at the pipe tip. When you drive the pipe tip, then we can use our steel steel shoes to set at the tip of the timber pipe. The tops of the timber pipe may also be damaged during the operation. The crushing of the wooden fibers caused by the impact of the hammer is referred to as a bruising. Or the damage of the top of the pipe. On the metal bundle or a cover may be used. Like this one. To collect the timber pipe, use this the taps. This is like the steel pipe. That's a collecting method. Is the same. And the next is of the sliver should be at least 5 times of the diameter of the pipe. The bottom end should be cut square so that further contact can be maintained. The cement point should be carefully trimmed so that they fit tightly to the inside of the pipe steel. In case of the matrix jobs and the boards, the bottom ends should also be cut square. The set of the span part should be trimmed for putting the straps on. When this timber pipe used in the water, in the sea, nearby the river, nearby the sea, then we can consider the environment to subject to attacked by various organisms. It can be done in a few months. Yeah, we consider the environment. We have a lot of corruption of the pressure of the tree of the table.
Yeah.
Yeah. When look is above the water table, the pad are subject to attack by insects. Insects. Okay. The depth of the pad may be increased by treating them with preservative, still such as this one. I don't know. Creosote. Creosote is what this man.
Chemical.
Chemical.
It's a chemical.
Chemical. Table pads. Okay. Yeah. Another type is our composition pads. Another continuous fluctuating a path. This is another uses the materials of the concrete and aggregates. Okay. I know some time. Okay. So this is just introduces the steps of the pad foundation about the steel pad, concrete pad, and timber pad. Yeah. Another combine with the materials together uses the composite pads, like the timber pad with the concrete. Okay. Yeah. So this is